Hello, and welcome to the Online College of Coding video tutorial series on Plasma Possum Advanced. This is video 1 of 9, and I'm your host, Daniel. Before starting this project, it's recommended that you've seen the Advanced Programming Concepts video and the Introduction to Unity. Let's get started. To make our Donkey Kong clone, Plasma Possum Advanced, we will be using the software engine called Unity 3D. Go ahead and fire it up now. We're going to create a new project, so click on the New button. Name your project, your name, Plasma Possum Advanced. Set your project directory location to somewhere appropriate you can easily remember later on. In my case, I'm going to place it on my desktop. Make sure you click the 2D button, as we're creating a 2D game. And now, we're ready to create our project. This process can sometimes take a little while, so give Unity a minute. Welcome to Unity. Before we kick things off, there's a small bit of housekeeping we should take care of first. Unity has many different layout options, and the one I use is called 2x3, with a few modifications of my own. The top right button up here is the Layout button. Here you can swap your layout to anything you like, for example, 4-split. All this does is just move Unity's tabs around on the screen. The modifications I make to 2x3 are simple. I like to make the Inspector, Project, and Hierarchy tab all as small as they can be. I make the Project tab 1 column instead of 2. I then take my Game tab and drag it up next to the Scene tab so that I can easily switch between the two tabs as needed. The next bit of housekeeping we need is to set up the Project tab. This tab represents the Assets folder inside your project folder. You can right-click anywhere on the Project tab to see the folder within Windows Explorer. This is the Assets folder. Anything within this folder will be mirrored in the Project tab, as they're the same thing. It's important to categorize your assets into folders within game development, as games tend to have many assets. Go ahead and create a folder for art, fonts, materials, prefabs, scenes, scripts, and sounds. Once you have your folders set up, we're going to want to import all the required assets we'll be using to build Plasma Possum. You will find a download link on the Online College of Coding website in the Plasma Possum Advanced course page. Once you have your Unity package file, open it and click Import on the window that opens within Unity. Next, it's time to save your scene. Navigate to File, Save Scene, and save your scene within your new scene folder. Name it Barrels. Chapter 1. The Level. The order in which you create a game varies depending on many different factors, and is usually a unique choice for each game. For a 2D platforming game like ours, it makes sense to start working on the level first, so that when the player is created, he actually has something to run on, rather than just dropping down into the infinite void. There are several objects that will need to be set up, coded, and spawned into the world. Things like the platforms, the ladders, oil drums, the hammers, the princess's dropped items. We will also have to place our enemy and the princess up on the top platform. To achieve all of this, we'll be creating a new script called the Level Factory. There, we'll be setting up what's called procedural generation, which is a term used in game development for code which creates via steps. The end goal is to have a script which can construct an entire level in the blink of an eye, with some random choices added in to give each generated level a slight difference. This means we can technically generate potentially thousands of different level configurations. The drawback to this method is that the levels generated like this often start to feel a bit generic and predictable without any further intervention. This is fine for what we're building. Create a new script and name it Level Factory, and open it up with your integrated development environment of choice. Start by including the generic library so that the custom variable type list is available here in this script.
Next, add 3 public asset variables to our script for prefab storage. Now we will create our own custom variable type called platform, which will be used to store all of the level data as it's generated by us later on. With the new variable platform declared, go ahead and use it as a list, as well as adding in the settings variables we'll need. Now we'll write the main function that will eventually call all the steps for creating a level, so that we will only need to call this one function instead of all the steps individually. Obviously, we haven't written any of the steps yet. Once we have, we'll return to this function to fill it out. The first object we will create will be the platforms. Platforms are the big long girders that the player runs along. They're made up of smaller individual pieces called rungs. Each rung is slightly offset from the previous one to give illusion of slope. Creating the platforms is going to take several lines of code, so we're going to break up the function into multiple parts. So let's start by writing the function header. Our function is going to need to store some data while it's working, and so it will take some local variables. Let's add them now. We don't want the slope of the platform to be the same each time, so let's roll a random number between 0 and 1, and if that number's 0, then flip the polarity of the slope. We want to generate more than one platform. This means we have to loop the process of creating a platform.
While looping through the platforms, we create a new platform called current row. We use this to store the Y position of the lowest and highest rungs of the platform, disable the lowest rung, and store the current slope value. We then flip the slope value for the next platform and add the platform to the list. After the loop is finished, we finally return the list of platforms created.
We've omitted 2 main steps from our function, calculating the position of where the first rung should start and the actual spawning of the rung. We'll take care of the position calculations first. The following will be going directly under the to-do position calculations line.
Here, we are initially setting the position to the bottom left of the screen. Then after the first loop iteration, we simply calculate the next starting position based off the previous rung's slope.
With the starting position for the platform calculated, we can now create the loop which builds a platform. The following will be going directly under the to-do rung spawn line.
So what's going on here? Well, while the position is still less than the right screen bound, we increment the horizontal position by a rung's width and add the slope if needed. We then set the type of rung to spawn based off the level bracket that you're up to. We then instantiate the rung, add it to this platform's list of rungs, and then set its parent object.
And finally, last but not least, we need to create the platform prefabs in the editor. The second object type we will create is the ladders. Ladders are important as the players can't actually get up any of the platforms without climbing one. Ladders are also potential drop points for barrels, but that's another story. First, we want to add any variables that we're going to need. Go ahead and write the function header, as well as the local variables that the function is going to need. Next, we need to make sure that the ladders don't spawn on the top platform, or too close to the platform ends.
So here, we're looping through each of the platforms, checking to make sure that there aren't more ladders than there are rungs, as we only have 1 ladder per rung. We also make sure no ladders spawn on the very top platform. and on the first and last 3 rungs of each platform.
Our function continues on. Now we start the second loop, where each loop is a potential spawned ladder. Still though, before we can actually spawn a ladder, we need to know if there's a free position on the platform.
So here we start the for loop that will eventually spawn our ladders. Before that, however, we start a small while loop that generates a random number between 0 and max per row, checking the rung ladder index list to see if that rung is already on the list. If not, a ladder doesn't exist here yet, and we can continue on to spawning our ladder.
We now have found a free rung index position that we can potentially spawn a ladder on. Let's roll some random chances to see if we spawn a ladder, a broken ladder, or nothing at all.
So what's going on here? Well, if the current loop number is higher than the minimum amount of ladders specified, then we roll a random chance to exit the current iteration, in turn forfeiting the extra ladder that this iteration would have granted you. Next, we roll a chance for the new potential ladder to be a broken ladder instead. If both of these chances have failed, then we are just spawning a normal ladder as usual.
Now it's time to create the ladder prefab objects and assign them into the level factory script asset variables. Make sure to remove the original objects from the hierarchy once the prefabs are assigned to their variable. The third object we will create will be the oil drum. It sits right before the bottom floor hole, catching blue barrels and spawning new living fires that chase the player down. First, we'll add the necessary variables for our following function. Unlike our platforms and ladders, the decision on where to place an oil drum is simple. Should it be on the left side or the right side? We'll be doing this check a lot throughout the project. And as is pretty standard by now, we need to make the prefab for our object. The fourth object we create is the hammer. Hammers are collectibles that allow you to destroy barrels and living fires. However, they don't make you invincible. You actually have to hit the target without it hitting you to destroy it. Obviously, we don't have the barrels or living fires yet, so they won't do much, but let's at least get them spawning into our levels. Start by adding the necessary required variables. The hammers are also simple to be placed, but it has to be done so for each platform except for the top and bottom one. And now we need to create the hammer prefab. The fifth object type we will spawn will be the collectibles. Collectibles are the princess's dropped items, including her handbag, hat, and umbrella. They give you points for collecting them, but aren't required. We need our assets, game objects, and settings declared. Add them now. The collectibles can be on any platform except the top, and on any rung which is enabled. When the collectibles are touched by the player, they'll need to be removed, so we're going to add the collectible remove function. And of course, finally, we need to create the collectible prefab, just like all our other objects. Go ahead and do this now. The sixth and last object needed is the top platform scene, which includes the enemy and our princess, the Gumnut. First, we're going to need the regular asset prefab containers and the game object variables to store the spawned copy. Add these now. With our assets ready, we're now ready to spawn those objects on the top scene. The prerequisite logic to spawning these objects is simple. We only need to know what side it needs to spawn on. And now finally it's time to set up our prefab objects. All that's left to do now is call our newly written functions so that the level is built. This is the final step in generating our complete level. You may remember back in step 1 when we wrote the level create function. It's now time to go back and fill this function. One last thing, finally, to make sure the level's built as soon as the game actually starts, we need to call our level create function in the start function. Congratulations! You've made it to the end of Chapter 1. If you've done everything correctly, you should now be able to save, compile, and play your game to see a full setup level. Stop and rerun the project multiple times to see how the level's randomness changes it each time. In the next chapter, we'll be moving on to the player and its inputs, such as moving and jumping.